Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome back. Thanks for joining me for another episode of the Reliability Matters podcast. I'm so glad you're with me. And today is a twofer, not one guest, but two guests today. Cheryl Tulkoff and Greg Caswell are authors of the new book, Design for Excellence in Electronics Reliability. It's more than 350 pages of valuable insight into reliability. Cheryl works for NI, we all knew them as National Instruments, and has over 30 years of experience in electronics manufacturing, focusing on reliability and failure analysis. She's passionate about applying her unique background to accelerate product design and development while improving reliability, optimizing resources, and improving customer satisfaction. Throughout Cheryl's career, she's had extensive experience teaching others. She's been a published author and a senior member of both ASQ and IEEE. She's also an ASQ certified reliability engineer and certified manager of quality and organizational excellence. Cheryl earned her bachelor's of mechanical engineering degree from Georgia Tech and a master's of science and technology commercialization from the University of Texas, Austin. Greg is recognized as a pioneer in surface mount technology manufacturing and has over 50 years of experience in the microelectronics industry. He was editor and co-author of the book entitled Surface Mount Technology. That must have been one of the first books, if not the first book, on surface mount technology, published in 1984. And Design for Excellence in Electronics, a much newer book, published in April of this year, 2021. He's also the author of over 270 technical publications. He's quite a prolific writer. Greg is past president of the International Microelectronics and Packaging Society, known as IMAPS, and recently received the Lifetime Achievement Award from that society. He received a Bachelor's of Science in Electrical Engineering from Rutgers University and also has a Bachelor's in Management from St. Edward's University in Austin. As I mentioned, Cheryl and Greg are the authors of Design for Excellence in Electronics Manufacturing, published by Wiley and available on Amazon and perhaps other places, we'll find out. We're going to give away a free copy of that book. That's a $130 value, at least. And we're going to give that away to one lucky viewer or one lucky listener. So stick around near the end of our conversation with Cheryl and Greg. I'll provide instructions on how you can enter to win a copy of their book, and it's certainly worth waiting for. So without any further ado, I'd like to welcome my guests, Cheryl Tulkoff and Greg Caswell. Thank you both for being my guests today. Today, I should say.
Thanks for having us, Mike.
Absolutely.
So you wrote a book. That must be a good feeling to have that behind you now and off the presses. That was quite a process, I would imagine, right?
That's an understatement.
Right. The question is, how'd you known how much work it would be? Would you have done it? I'm sure the answer is probably yes, but I don't know. Maybe not.
Well, I think it's one of those, like everything, you think it's going to be a lot easier than it is. And then once you get in, you see it through. But it definitely took a lot of twists and turns. It took us much longer than expected to pull it off. But we're glad to be on the other side and glad to finally get it in people's hands.
I'll bet. It was published just recently, right? It's a fresh publication?
Yeah. April of this year.
Okay. All right. And you're starting to see some of them fly off the shelf or creep off the shelves?
They are definitely selling.
Well,
we've gotten some good interest from folks across LinkedIn, and so I've definitely had all kinds of peers reach out and express some interest, want to read more. So it's been fun.
Well, neither of you are
like I was mentioning before. I've had two customers lately that have the book on their desk right in front of them, and say, you said this in the book. How does that apply to me? And you have to kind of remember what you said in the book and then translate it into what you need to do for them in real time. So
you may have written that at 3 a.m. in the morning, 3 years ago, and all of a sudden it's brought back into a different context, and your readers expect instant recollection of what was in your head at that moment, right?
Mm-hmm.
Yeah, that's the thing about words. I mean, they're permanent, right? So that's the reason for good editing and good review and rereads. And I'm sure there's a lot of prior versions on the cutting room floor before you were satisfied with the final result. I wrote a book recently. I don't know if I'll ever publish it or not, but I realized the art of writing a book is definitely an art form, and everyone does it a little differently. My MO was to write it and put it on the shelf for 6 months, and then pull it off the shelf and read it again. And sometimes I'd go, well, that guy's good, and sometimes I'd go, what was I thinking? So it's definitely a long experience to do something like that.
Yeah, we had a lot of moments like that, and of course, COVID came in the middle of everything as well too, and changed things up. But even we were surprised at just how many edits and re-edits, and we'd swear how many times we were proofing each other's work and had other people proofing it and peers, and it's like, how did we miss that?
Right.
I didn't mean to say that.
Right.
So.
Well, time is a great tool for reviewing your work.
Yeah.
You look at it from a different perspective. Your head's in a different place. Maybe not quite as much with technical work, because technical follows rules that are still the same rules 6 months later. Creative writing probably changes a little bit because there aren't quite so many, hard, fast rules. But either way, it's a long process, and I cheer on you guys. I wish you all the best success with the book. And we're going to be, as I said earlier, we're going to be giving a copy of that away to one very lucky viewer or listener. Let's start with your background in our industry. Let's start with Cheryl. Tell me, where'd you come from? What were you doing before you entered this industry? What brought you to this industry, and what has your journey been throughout this industry?
Absolutely. Well, it's definitely been a circuitous path, pun intended there, but I've always been in the electronics industry, basically since I graduated from Georgia Tech with a mechanical engineering degree. So that was my first job out of college, was here in Austin, where I still am today. IBM brought me out here at the time, back when they were making printed circuit boards from start to finish, fully integrated. They were doing the laptops here, the PS2s back in the day, early portables, and then box builds for some of the systems, things that were going on. And I just absolutely fell in love with manufacturing. So I was a process engineer, and that's really where I got my start. And that was right at the era when there was still a lot of solvent cleaning. So that began the transition into the chemistry of processes as we were converting from solvent cleaning to no cleaning to water wash, and all different variations in there. And so I worked at IBM for a number of years. And IBM was gradually starting to get out of actually building things. And so I took that as an opportunity to move into the fabrication side of things, chip fabs. And so Cypress Semiconductor was my next stint, again, here in the Austin area. And so I had a chance to work in fab, again, as a process engineer. But my focus then was the first time on defect reduction. And so I had all the great toys in a fab, making programmable logic devices and static RAM. And so that was SIMs and EDXs and protocol counters. And so it was the way to kind of see the industry, but still in the manufacturing world. And so I really enjoyed that experience. And of course, that started the kind of the high-tech detective work that became kind of the defining elements of my career going forward. And then Cypress shut that facility down as they were transitioning into 8-inch and then overseas. And so that's when I first went to work for what was known then as National Instruments, now NI. And so there I worked in process, but began taking on the quality and reliability roles. And so we were standing up a reliability program at the time from scratch, setting up Halt and Hass and lifetime testing. And so I did that for a number of years, and then had the opportunity to go to work for DFR Solutions at the time for a number of years. And again, another great experience that took me all over the world, where Greg and I first began to work very closely together with clients across all different types of industries, helping them look at how to make electronics more robust and reliable. And so that's really where we began to kind of craft a lot of the things that you see in the book, because industries are very different, environments are very different. One process or one component can be great in one application and horrible in another. And so that's when we began to develop a lot of the concepts and the ideas that you see in the book. And of course, after that, I came back to NI to manage the company's global quality program, and that's where I am today.
Awesome journey. First of all, you had me at PS2. You didn't even need to go past that. And second, just I always ask people who are ex-IBMers if this is true. IBM, some say the acronym for IBM is not International Business Machines. It's I've been moved. Is there truth to the I've been moved part of it? It's like see the world, join the Navy, or see the world, start with IBM.
It wasn't that. I don't think I would have called it that case for me. I was working out of what we called ECAD, Electronic Card Assembly and Test, and in Austin we had everything except chip fabrication here for IBM. So we had a panel plant, fabrication facility, we had the assembly and test, box build, repair, and rework. So I did get the chance to travel and visit global sites for IBM, but I wasn't relocated, and it was like a great experience because we had almost all one thing in an original campus. And for those people who live in the Austin area now, it's become like the super mega shopping center called the Domain, and I work near there now, and so it's really weird to see how they turned it from this enormous facility into upscale shopping.
Yeah, excellent. There was a mall in the Bay Area where I grew up, in the San Francisco Bay Area, that was some type of mall and HP bought the mall and turned it into a business park for HP. Yep. Who knows if it's back to be a mall again? Probably not these days. Greg, tell me, same questions. Tell me about your journey. You've been around for 50 years in this industry, so I imagine you rolled out of bed, graduated, teething, and then started working in this industry. I mean, it seems like most of your life.
Well, I tell people around the ANSYS that I'm the old guy. And my career kind of started going to college at night in parallel with working for Burroughs Corporation in New Jersey. And I worked on the Iliac 4, which kind of dates me. And from there, went to RCA, where, like Cheryl, I got to work on the fab lines, making the integrated circuits in both silicon and silicon on sapphire. And I got involved in the first project to develop leadless chip carriers and surface mount processes, if you will, back in the mid-70s. And then translated that into coming down to Tracor Aerospace here in Austin in the late 70s, where I set up one of the first SMT manufacturing lines in the United States. And on that line, we actually built the first SMT electronics to go into outer space. The book came together as part of working with 13 other chapter authors, and we put together the first book on SMT that you mentioned in 1984, and it was kind of sponsored by Isham, which is IMAPS today, and kind of brought together what I called, the 14 wizards of SMT back in that time frame. And from there, I moved on up to being a chief engineer of a division at Tracor, and then a couple of colleagues and I started our own company here in town, and that's how I kind of moved over into the contract manufacturing side of things and spent the next 30 years or so doing contract assembly for different folks and working for a couple of different outfits here in town. And then went to work for a nanotechnology company in Maryland. And it was a good idea at the time. I started working for them. Things were going along pretty well. And the money kind of stopped from the investors, and the company went out of business, essentially got sold to another company for a really inexpensive price. And that's when I started working for DFR Solutions, which is now almost 12 years ago. And I'm still there through the purchase by ANSYS 2 years ago. So that's how I got to where I am now.
Very good. And how does Greg and Cheryl, how do you guys know each other? Other than everyone in this industry seems to know everyone in this industry, but to get together and collaborate on a book tells me there's some history there.
Well,
Well,
both of
our
us,
history was,
yeah,
yep.
go ahead. We're both going to say the same thing.
Was
That
it
we
the
both worked at DFR
DFR, right?
Solutions
Okay.
for several years and worked on a lot of projects there together, and then got together in the thinking process initially with our former CEO Craig Hillman to put together this book. What 5+ years ago, I guess the idea manifested itself.
Mm-hmm. Yeah, I realize that sounded like a silly question since I know you both worked at the same company, but that doesn't always mean you hook up with someone and decide on this multi-year project to write a book. So no, that's perfect. Thanks for answering that. Let's talk about reliability.
Well, I can give you a little more context there.
Oh,
too,
let's do that, Cheryl. Here comes the real story, Greg. Here comes the real story.
Yeah, there you go.
But I mean, like you said, just because you're coworkers doesn't mean that you're necessarily going to commit to writing a book together, right? But that's where, Greg and I just seem to have a lot of synergy in our focus areas and interests in. We'd started doing publications together and talks together, for SMTA, IPC, and other groups, including clients. And we worked on a lot of projects together. And so we had a lot of experience editing and writing together already before the book. And then also had, I think you were talking about the why, why write a book, that similar perspective of, because we see so many clients seeing the same things over and over and going, and, it's really sad. It's great to work on problems, but we want them to be new and novel and different, and not people having to struggle with things that we've already seen solved that the industry knows how to solve. So.
Oh, there we go. That makes a lot of sense. Let's talk about reliability from a press box view, at least at first. I've talked to a few people about reliability when I started this podcast called Reliability Matters, right? So I wanted to get into all things reliability, and I had more than one person respond when I asked them about, what's your reliability program? These are smaller companies, and they go, and they would refer to our QC program, blah 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 blah. And I'm like, no, reliability. And they go, well, yeah, quality. So is it common for people to kind of mistake quality for reliability? I see the shaking heads. I think we're all in agreement there. Mm-hmm. So tell me, in my audience, and more importantly, the difference between quality and reliability.
So, the biggest difference for me, and there are a few that you chat about while we're here, but the biggest difference is we're talking about time, the duration of the time and the environment, because you can make something with perfect quality and it can be completely unreliable. Once you get it out there in its actual use conditions or the stress that you put it under, it falls apart, but you made it exactly how you intended to, exactly how it was documented, exactly what the instructions said. And so if you think about it from a factory perspective, they did their job. It's a quality product. We made it exactly the way it was specified and designed, but that doesn't mean reliability at all. So you have to match that to the expected use environment and over time to get to reliability as over and above quality.
Yeah, I would suppose if you take a consumer device and stick it on a spaceship and put it in space, it may not last very long. However, there was nothing wrong with the quality. It met 100% of its quality marks, maybe even more. And
absolutely,
yet it's use, and we're going to talk about fit for use in a little bit. We're going to get there, but I guess that is a good difference. Greg, any color commentary on that?
Well, I look at several things where you talk about some of these high reliability situations with customers. And yet we're seeing, for example, with spaceborne applications that some folks are utilizing automotive grade components because they've actually been screened by the manufacturers to a level somewhat comparable to the Class S parts for space. So, they're getting a little bit more bang for their buck with that kind of utilization of a not as high rel component on paper, but performing quite well regardless of that. So, there's kind of a transition to a better reliability there as well.
I spoke with someone, on this show, maybe a couple years ago. I forget who he was, and the part that he was speaking about specifically. But to your point, he said that, the space agencies, NASA would be far better off grabbing a couple of, maybe 4 automotive parts and put them as, one primary and 3 redundant for a fraction of the price of one part that was spec'd into, space standards, because the chance of 4 commercially available off-the-shelf automotive parts failing is actually much less than one part built for one application for one customer, because they just can't have the history behind it. They don't have the thousands or millions of hours of test data behind it. Yeah. Right. Exactly.
And that's such a great point, because there's more than one way to achieve reliability, and that's what you talk about in the book too, right? Greg gave the example of the part itself, choosing parts that are rated for certain environments, but you just mentioned redundancy, right? So you can combine methods to come up with the most cost-effective method for achieving the reliability you need, but you have to know what reliability you're aiming for to get there.
Yeah, one of my favorite subjects when it comes to reliability is the automotive industry, because the automotive industry is slowly transitioned from a completely mechanical assembly industry that purchases a few electronic gadgets here and there to, 20, 30% of their bill of materials are now electronics, maybe more, and melding with and mixing with the mechanical side. Tesla, for example, was long criticized in the early days of their overall assembly quality, because they were a high-tech company. They were a software company that built cars. They were not a car company that built software. And I think they had to learn a little bit how to be a car company, right, and get that part down. But unlike the aviation industry that has, one primary and 2 redundant computers for pretty much everything on the aircraft, the auto industry has one system that typically performs a variety of tasks, and very little redundancy, if any. And that's okay when the electronics are, infotainment, when they're your seat massagers and seat warmers and coolers and climate and XM radio, satellite radio stuff. That can all fail, and it's not going to kill you. Now, in today's modern day, with most cars, not just electric cars, but most regular cars, we now rely on many of these features to keep us safe. We no longer look over our shoulder. We look at the blind spot indicator. We no longer really we don't practice the safe driving skills that we grew up practicing, because now we have systems that take care of that for us. Cruise control. Adaptive cruise control. I used to, the first car I had with it, I would always hover my foot over the brake, just ready to catch it when it failed, and it's never failed. Same with blind spot indicators. I find myself not turning over my shoulder anymore. I trust the system. And if those systems break, if there are reliability issues within those systems, now people can get hurt or worse. And there are no backups. So they really have to be designed as well as, if not better than what we see in the aviation industry, because aviation is safe because of redundancy, and cars don't have the same redundancy. So that being said, I'm going to drag us back a little bit so we don't get too far ahead of ourselves. What's the best step for a company that realizes they need a reliability program? Where do they start? I think a lot of companies just circle around the subject, but they don't know where to take the first bite. So what's a good first step in establishing a reliability program?
Well, the first step is being aware that you need one. It's in a lot of the startups, the common thing now is fail fast, minimum viable product, get started, get something out there. And so you see, for truly small companies or companies getting started, they're really focused on making something work, right? So they're not necessarily focused on the long-term quality or reliability, because first they've got to see, is my idea even going to cut it, right? So you see companies will get started there, but you need to begin to think very early on about the necessity of having it and how it's going to be used. Because we talk a lot in the book in the need about understanding the customer, how they're going to use it, and the use environment, because that's the first steps toward being able to design for that your device for what it needs to survive, is knowing what you're trying to design for. And you do some early work just in the creation side before you move into that. But awareness is number one, and then how's it going to be used is number two.
Yeah, makes sense. Greg, tell me about in-use environment. How important is it to know where the product's going to be used?
Understanding the use environment and the stresses that the product might see during its intended lifetime. It's kind of fascinating when we talk to prospective customers, and you'll say, well, what's the operating environment for your product? And they'll go minus 40 degrees C to plus 85 degrees C. And then you go, no, that's not the operating environment. That might be your spec limits, but what is the actual operating environment? And we have this occurs over and over, and trying to explain to folks that, no matter where you go around the world, the delta T in temperature each day is about 15 to 20 degrees centigrade. And it's just a matter of where are you and where are you on the scale. But they, they're hung up on their spec. And so we have to kind of teach them what the use environments really are, thermally, vibration issues, drop shock. We get to cover all of those different environments and make sure that the customer understands them so that we can proceed with, kind of putting together a viable reliability assessment.
Yeah, and I'm a big runner, so I'm going to give you a running analogy. So, one of the things that's, common for first-time runners training for something is, how do I train or where do I train? And we're in Texas, so it's hot. So a lot of people are like, well, I'll go to the gym and I'll run on the treadmill, right? And I'll build up my mileage. I'll become a really good runner on the treadmill. But if you're training for a trail run and you do all your training in the gym on a treadmill, you are going to be completely reliable once you get out there, and you have to face the heat and potential wet and mud and rocks and sticks. Your shoes are different. Your gear is different. The clothes you wear is different. The things you carry with you to eat and drink are different. So you did the training. You could be perfect under those circumstances, but horrible once you get on the trail to do that actual run because your training or your design environment did not match your use environment. And that's exactly what happens in electronics too. Again, back to that quality side. Build it, works perfectly, but you put it out there in the sun or the heat or the cold or vibration and shock, and it literally is like, I wasn't designed for this.
Right. Works well in a lab. Get great numbers in a lab, Put it out in the field, and all things change, right? I think that's one of the big challenges with Internet of Things, with IoT, is we're putting electronic devices in things that have not historically had electronic devices in them. Not necessarily, for those who listen to the show, they know I kind of go crazy about this, but not because we should, but because we can, right? Particularly in today's days of severe chip shortages, we're still building devices that serve no purpose except just just for effect. But at any rate, IoT, a lot of IoT is class 1 device, right? It's just consumer stuff, junky stuff that performs some interesting act. And I'm thinking like a connected toothbrush or something. They actually do sell connected toothbrushes that can narc on little Johnny or Jamie when they're not brushing their teeth for long enough. But that definitely is not a class 3 device. It's not going into space. No one's going to die if it fails. And yet it's still subject to running in a harsh environment. Therefore, it has to be built closer to a class 3 device than maybe a traditional class 1 device, electronic flea collar or something like that. So I think we're seeing a lot of emphasis on reliability, even on parts that may not have otherwise been subject to that level of scrutiny from a reliability standpoint. Not because people will die if it fails, but because the company will lose its reputation, have to replace a part. It's just electronics now are just expected to last. The term "there's no moving part, so it lasts forever" not technically true, but that's what people think. So there does seem to be a greater awareness now of reliability all throughout the classes, class 1 through space, really.
Yeah.
Let's talk about manufacturing. I've seen several examples. I know you guys have definitely seen several examples of things that are expected to last, expected to have a certain reliability expectation, but they're impossible to build. So there is a design for manufacturability element. That seems to be one of the first steps in reliability, is making sure the part can be manufactured to be reliable. However, whatever that entails. Tell me about the importance of design for manufacturability, and how much can that change the reliability outcome?
DFM, in my opinion, is one of the most critical applications that you can get involved within an overall design for excellence program. You have to look at the materials, the components that have been selected for the application. You have to validate through analysis that they are going to survive the intended environment. The circuit board laminate. We get a lot of people, I ask them, what laminate have you chosen? And they go FR4. And I go, which one? And they go FR4. And I kind of let them know that there are 700 materials out there that fall into that category. And, if you just leave it wide open for your fabricator, you're not going to get the same thing twice. So that's a manufacturing related issue that can come out of an incorrect specification, if you will. We see a lot of issues with materials from a manufacturing perspective, things like conformal coating and whether they're the right materials. Again, over and over, I will see situations where the coating material has what's called the glass transition temperature, and it's right smack in the middle of the operating temperature range. What happens then is that every time you go from hot to cold in your operating temperature range, you put an excessive stress on the solder joints and the parts. So again, a design-related issue that translates into a manufacturing problem. And so you've got to have the right materials, the right process, and make sure that you can, validate all of it. And that's kind of what we mean with reliability support.
I do have to correct you, Greg. You said 700 versions of FR4. There's actually 701. Cheryl and I were both hired as expert witnesses on a civil litigation matter between a IP holder and a contract manufacturer to put together their IP. And the statement of work that they gave to their contract manufacturer was under the board material was, and I quote, down and dirty FR4, nothing special. Down and dirty FR4, nothing. So I'm thinking the down and dirty, nothing special, or a slash sheet that was previously unaware of. Right. Do you remember that, Cheryl?
I didn't know about.
Say 701, down and dirty FR4, nothing special. But I see your point on that. Yeah, absolutely. They would have been, Cheryl, the case you and I worked on together was a classic example of not designing for in-use environment. They had a battery that was supposed to last 10 years. They had a severe calf problem, some corrosion issues, dendritic growth issues, and the first thing all that did was drain the battery, which lasted 3 months, not 10 years, and it was a big mess.
Yeah. Well, we've seen things once they've gotten to the manufacturing line. I'll give you a quick example because this one was kind of fun. You've got to apply conformal coating during the manufacturing sequence. The material in this case was a conformal coat that I was not familiar with. It was manufactured in China, and it had a 2-hour curing time at 76 degrees C. Pretty standard. So when I audited the manufacturing facility, I went to that operation, obviously, recorded a board going into the oven to cure the conformal coating, and the board came out 4 minutes later, clearly not cured. and yet was packed up and shipped across town to a sister facility where they put together these assemblies and integrated them into the final assembly. So the issue of trying to speed up the process actually got pushed across town, where that facility, all the operators had to wear cotton gloves. Would have been good, except they all cut the fingers off of them so that their gloves wouldn't stick to the tacky boards. So a second problem came out of the first manufacturing issue. And it was all about, making the shipments faster than they should have been. Got both of those resolved, and the yields went up over 25%. So paying attention to the manufacturing operations and watching how people function saves time and money.
Yeah,
and I think that's a kind of a critical element there too. You can't manufacture reliability but you can certainly wreck the quality of things in manufacturing by overly complex processes, by difficult to assemble parts, complex systems, and a lot of those we have. And so that's where the design for manufacturability really comes into play, because that's where the quality happens, and that's where the cost can really kind of spiral out if you're trying to compensate for things. Looking at Greg's issue that he was just talking about there. They're trying to get out certain amounts to hit volume targets or things, and they start adjusting processes. But one of the things that I always appreciated about when I was in manufacturing engineer, were those designers who would actually come to the floor and try out, see what it was really like to try to put some of these designs together and kind of work interactively. Because, as engineers, a lot of times we fall back on documentation, right? Oh, we can write up just better instructions. And if you just read the manual, and who reads the manual? You're right. Have you read the manual for your automobile? Do you read the manual for, no one reads the manuals. They skim it at best, or the quick start guide. And so, for me, one of the things that's like I aspire to is what I call the Lego version of instructions, right? You got pictures, you've got numbers, and then it's intuitive or obvious on how it goes together, right? So it's not, cumbersome to do, and you reduce the likelihood of mistakes, which increases your quality. You get it right the first time, it's cheaper, it's better. And so there's a lot that has to go in, to make those things happen. And Greg and I can both share lots of, challenges. And again, those things where one small thing that they're trying to compensate for, they're cutting the fingertips off so they don't stick, or so that they get better things, or grip power. And then, they're either transferring body oils or, cascading other things. And before you know it, you've got not one, but 6 or 7 problems that you've created by a quick fix.
Yeah. Let's talk about mistakes. I think we learn more from mistakes than we do from successes, right? So, because we don't know if success is lucky, and mistakes are generally not just unlucky. They're usually a result of our actions. What are some of the common mistakes made when considering a reliability program? Let's combine the other question that I was going to ask, the myths regarding it and mistakes regarding it. What do people get wrong when they're talking about implementing a program, or when they implement it for that matter?
There's several different myths associated with kind of kickstarting a reliability activity, and that's, I kind of go back to, the design. We don't need to worry about working with the designers, because they're just going to kind of throw it over the fence to us in manufacturing, and we'll have to figure it out. And that kind of is a major potential issue. Some of the selection of materials, like we've talked about a little bit already, the types of activities. I don't know, Cheryl, do you think, you have a couple of the other thoughts on what the...
I have some definite opinions about things that make me crazy.
Cheryl's in the background going, I know.
Well, I've got just a lot of pain points around that. So the biggest, one of the biggest things is not having a definition of what it means to you, right? If you ask, and Mike, you've been interviewing lots of people. Everybody, if you ask them at their company what is quality and what is reliability, you're going to potentially get a different answer, and for legitimate reasons. What is high reliability in consumer applications, kids' toys, is different than high reliability in medical devices and high reliability in aerospace and cars. And so it's not just one number, but it is a number and a real target. And for many places, many companies, it's very nebulous. They would said, oh, well, we want to make high reliability. Well, what does that mean? Well, high reliability. It's like, well, how long does it have to last? Under what conditions does it have to last? And, you have to design to a target. And without that target, again, and having those targets very early on, to Greg's point, you're not going to pick the right materials. And it works both ways. You can over-design something as well as under-design. You want to be in either direction. If you over-design it, then you're pricing your product at a place where it doesn't have to be for what you need. But if you underdo it, then you're not going to meet the needs of that audience either. And so that's, again, once you have the targets and the goals, those are the things that lay the foundation for picking the materials, picking the appropriate processes, and being able to hit those targets. Because where else do you have someone go in and not have a defined criteria for what their design needs to do, right? Right,
exactly. Before we get into your book, I just have one question, and then we need to move on to your book. I want to ask you about quite a few things about that. Where does reliability begin? What's the genesis of reliability in a manufacturing process?
Well, reliability has to begin in the design process, and it has to begin at concept stage. Manufacturing is too late to have a reliability conversation. You cannot manufacture reliability if the design wasn't built for it or designed, to accommodate that.
So it's important to factor in the design stage, the end use environment, the expected life of the product, the cost of failure, any other types of factors that one should consider when they're designing a product relative to reliability?
What I think one of the things that I always look at is what is the field environment? We've talked about the use environment quite a bit, and I think that becomes one of the pacing items for kickstarting a reliability program. Where is it going to go, and how do I limit my exposure? How do I select the right materials that have to survive the environment? And I'm amazed at how many folks don't actually grasp what their field environments are, and they need to, as part of the start of this program early in the design cycle, so that they select all the right materials, parts, circuit board, and so on, right at the beginning of the process.
Yeah, and to add on to that, other things that are part of the whole reliability equation that we also talk about in the book are in the design phase. You have to think about repairability, supportability, recovery as well too, because things will fail. It's a matter of time. And so what happens when they fail? Can you recover quickly? Can you repair it? What does it mean from the sustainable? Or is it, when it breaks, you throw it away and it's waste? And so those things are important too, because when you think about, okay, if I want to repair it, I've got to make sure that I can disassemble it, that I have access to things. And Greg can probably tell you the number of times we've seen people put fuses on products which are meant to be replaced, and there's no way to access it. So you've essentially, you have to rebuild it to be able to access a replaceable fuse, because someone wasn't thinking about how someone was actually going to get in and be able to replace the fuse if it did blow. So you have to think about those, especially in bigger systems, ones that are really intended in those industries for long life. They're going to expect them to be repairable and supportable.
I remember working on some cars that were designed by engineers that decided they would make it really difficult to access something that needed to be serviced. I think of old GM cars with the distributor between the firewall and the back of the engine block. They even made a special wrench to unscrew the distributor so you could adjust the timing. And the wrench had all these different contortions to it. It's only used for one application. That was so that you can get there. And I can only imagine the meetings, like, where are we going to put this? I'll just put it here. Well, you can't reach it. No, I've come up with this crazy wrench, that one in the world wrench that can actually loosen the distributor.
But
Similar to that.
sadly, they probably did not have that conversation at the time. They're like, we can fit it here. And only when it broke or someone went to try to service it did someone go,
uh-oh,
and then
yes,
go back and design.
yes, that's probably true. That's probably true. That makes a lot of sense. Let's talk about your book. I asked you at the beginning, I don't think I quite asked you this question, but what inspired you to write it? What made you sit around working both full-time jobs and having your lives and your running and all this kind of stuff and go, let's carve out a few years to write a book? Whose idea was it? Where did that come from? What inspired it?
I think there's a combination of things in there. First, I mentioned earlier, just seeing the same problem being solved over and over. And that's frustrating as an engineer. Once you've gotten a solution out there and you've shared it or made it available, you really hate to see other people make the same mistake. It's not good for us or the industry, to have that happen. And so that was part of it too, is, we got to make it easier for people to be able to find the information and kind of this body of knowledge. And a lot of the books out there that we did see, were really more like what I call the super technical, not the more practical, how to do it in the manufacturing, how to combine these elements together. And so that was a part of it, certainly. And then again, just that, impatience and frustration at having to write that same thing over and over. I've already written that we solved this. I'm doing it again.
Yeah. Same with you, Greg. Same motivations.
Pretty much. We've both seen issues. I'll just give you an example. Back when supercapacitors kind of made their presence known in the industry, everybody went crazy to put them into their systems. What they hadn't looked at was, were those parts going to behave reasonably in all the myriad of applications? And the problem was they didn't. And so, that, I think I probably had 10 customers that came to me with the same exact headache utilizing that type of component, because they jumped in with both feet without exploring it first. And so we had to solve it, but it was over and over and over. And, you reach a point where it's like, but I can't send them the other customer's information because there's a non-disclosure. So I have to give them a whole new write-up, like Cheryl said. And it besides being monotonous, kind of is frustrating because, they didn't have a place to go to figure that out.
Yeah.
And that's what we hope the book does.
Walk me through the book. I'm a young company. I decide we need a reliability program, or I'm an old company and decide we need a reliability program. Is this book written for, I don't want to say a beginner because that's a relative statement, but a beginner in reliability? Manufacturing engineers, electrical engineers, we'll make that a given. Is this a entry level, intermediate level introduction to reliability? Is it an introduction to reliability, or is it an advanced course on reliability, or is it all of the above?
I think we cover the basic elements of a reliability program in the book, and in some cases we do some pretty deep dives because of the necessity for understanding that particular element or elements of the overall reliability program. So I think our intent was to not make it a book specifically designed for reliability engineers, but for others, electrical, mechanical engineers, so that they would understand reliability, and if they had to work with someone in their organization, would have a better understanding of how to do that.
Yeah, and we really approached it as like a handbook, right? So, the intent was not to make a theoretical, foundation where we really focused on all the physics. As Greg mentioned, there's some that are unavoidable, just like some math that's unavoidable in there. And so we included those where we thought it was fundamental that people at least have that reference to understand the grounding for why these things happen, why you can't violate certain laws of physics, to accomplish what you're doing. But, we did intend to make it more accessible so you don't have to be, an expert in the field. You don't have to be a guru. You don't have to be a chemist or a physicist, to be able to use this. So it was aimed at, the working people, whether they were technicians, engineers, folks in manufacturing. We think there's, certainly the content was our intent that it's approachable by people of a pretty broad range of backgrounds.
Walk me through the book. Tell me some of the key elements of the book from chapter 1 to chapter whatever. I know there's a lot of chapters. I think I counted like 301 pages, including the index. So that's a lot of content. So kind of walk me through the key subject matters of the book.
Yeah, it's, we kind of start off with, like you had said earlier, identifying, the characteristics of a reliability program. What does it take? Who are the people that need to be involved? What do they have to do? How do they work as a team? We have chapters on design for manufacturability, design for reliability, test plan development, because one of the things that comes out of doing proper reliability assessments is being able to define the proper test plan to validate the new product or the product that's being assessed.
Yeah, and of course, a lot on problem solving, failure analysis, because again, things are going to break, they're going to fail. And what's important is to understand why, to keep it from happening again. Obviously, we think all the chapters are important. We try to kind of create as much as we can the foundation first. So why? Why is it important? What's the problem we're trying to solve? Why it matters? And so that's the framing and the intro, and then the foundations of the program itself. As we've mentioned a lot, you have to understand, what you're designing for, and how long you want, that use environment, how long you want it to last, and then everything just continues to build, because it very much is, a foundational program. As I mentioned before, you can build it great, but if you make poor choices in materials or characteristics, it's not going to, fulfill its intention. And so we do spend a lot of time, setting that up. And then, Greg mentioned also too about the test plan development and how to actually test. And I mentioned that earlier in my running analogy, is that there's no industry standard that's going to substitute for the actual use environment you have. Those can be proxies, they can speed up the early development, but you still have got to get out there and test and do these things in ways that are representative of what your product is going to see. Otherwise, it will just fail in things that you haven't tested for and haven't thought of. And that's one of the things I think is really critical that we spend some of the time in the book about as well, too, when you're talking about the problem-solving process, is, the risk assessment. And that's where I think you see some really great work going on. You mentioned the auto industry earlier, right? So much electronics in there. Now we're talking autonomous vehicles. We're talking about really upping the stakes for those things. And you're only going to spend so much on a vehicle. You're not going to spend space shuttle prices for the car you drive around every day. So it's got to be at a price point that's affordable. So the industry has really adopted a shift in that thinking, and it's risk-based thinking. So you see a lot more work on failure modes of effects and analysis, which we talk about in the book. We talk about redundancy and picking the right parts, but it's all about actively coming up with scenarios, and that's where some of the things that Sherlock and ANSYS is doing now with the modeling. What can we do to run it through its paces before we ever even build it? Inject faults and see what happens, and you use those tools to help us make better choices early on, so things don't fail, or if they do fail, they fail in safe or more predictable fashions. And so we spend a lot of time in that. And of course, Greg and I spend a lot of time in failure analysis, and there's a lot of really cool activity going on there. So we cover those techniques in a lot of detail. And then at the back end, the documentation side, as well as the sustainability and supportability sides that I mentioned earlier, right? Is it repairable? Is it serviceable? Is it, a throwaway? And then in terms of sustainability for the environment, we've got to take responsibility for the waste we create and the materials that we use for the people who work in them, globally as well too. And so those things, have to factor in, and you see a lot more of that in designs now where they think about that sustainability piece as well too, is the full life cycle.
In 30 seconds or less, that's hard to do, by the way. What's the key takeaway that you hope your audience will get from this book? Greg, let's start with you.
I want readers of the book to do what I mentioned to you earlier, and that's, they've been calling me and they've got the book in front of them, and they want me to kind of talk to them about how it applies to their particular situation. And so, I do. And then what the book has done is given me the opportunity to help another new customer get involved properly with reliability and possibly solve a problem very early in the design cycle so that they don't have a problem, rather than experiencing headaches like they would have if they hadn't done that in the first place. So that's one of my favorite things.
And it could be a product that you end up buying someday. So that could actually be self-serving too, right?
Could happen.
How about you, Cheryl?
And for me, it's much simpler. It's design with a reliability goal, and design with that end in mind, right? Have that goal and design with that goal in mind.
Yeah, short and sweet. All right, we promised our audience we're not going to string you along any further. There is a way to win a copy of this book, and that is to send me an email, mike@mikeconrad.com. That's Conrad with a K, mike@mikeconrad.com. In the subject line of the email, mention the word book. And that's all you need to do. You can tell us more about your application. You can tell us more about yourself and your company if you like, but be sure in the subject line you mention the word book, and my team will make sure that you go into the drawing for a copy of Design for Excellence in Electronics Manufacturing. Cheryl Tulkoff and Greg Caswell, thank you so much for writing the book, and even more importantly, being my guest today, if I can be selfish about that. Thanks for sharing your wisdom on reliability, and it's always good to see you, and even better to talk to you. And I wish you all the success in the world with your book. I don't think you're going to need the luck. I think you've already put in the work. I think it's going to manifest itself, but I'll be happy to watch it climb the ranks of Amazon technical books. And I do see it's on Amazon. It's about $10 off the retail price on Amazon. Are there other venues to buy it, or that you would recommend, or is Amazon?
Barnes and Noble.
Barnes and Noble.
You can buy it, and directly from Wiley, who's the publisher.
Excellent. And Wiley's known for a lot of technical publications, right? That's what they specialize in. Is that correct?
Yes.
Yeah.
Yes,
Wonderful.
this is specifically from their reliability and quality line of books that we're in. And in addition, you can get it in hardback as well as ebook and different e-reader forms too. So these bring a little bit different way to consume the book, ways to create notes and track your progress as well.
Wonderful. Well, thank you both very much for being my guests. Again, good luck with the book, and I'll look forward to seeing you at live events sometime in the hopefully near future.
Exactly.
Thank you.
Thanks, Mike.
Thank you. Thanks for listening or watching the Reliability Matters podcast. Be sure to subscribe to the podcast on your favorite podcast app, such as Apple Podcasts, Google Podcasts, Spotify, and so many more. Also, be sure to check out my other podcasts, including the Concept to Creation podcast, where I feature conversations with entrepreneurs within the electronic assembly space, and the Innovations in Technology podcast, where we discuss innovative products within our industry. All three shows are also available in video format. Check out the Reliability Matters or Concept to Creation or Innovations in Technology podcasts on YouTube. Just search the show's name and you can find all three shows. Or go to mikeconrad.com. That's Conrad with a K. All three shows also appear there. Again, thanks for being part of my podcast family. I appreciate you being here. Until next time, stay safe, stay healthy, and stay happy. And of course, keep doing it right. See you again soon.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.